1999. A physicist in a Harvard laboratory is about to see something no human being has ever seen before. Her name was Lene Hau, Danish by birth. She trained first as a theorist, then taught herself the experimental work most people said she shouldn't try. For years, she had been building toward this exact moment. Light, in a vacuum, travels at a fixed speed, roughly 300,000 kilometers a second, one of the most stable numbers in all of physics. But light slows down inside a medium, glass, water, air, even, very slightly. Ordinary materials bend and slow light a little. Hau wanted to know how far that slowing could go. Years earlier, working with a colleague named Jenny Golovchenko, she'd built a key piece of the source. They called it, informally, the candlestick. It wicked sodium atoms straight out of molten metal into a beam. That beam fed separate laser cooling stages, developed over the years that followed, which brought the atoms down to 50 billionths of a degree above absolute zero, cold enough that they stopped behaving like separate particles and merged into a single quantum state, a bose-einstein condensate. Using a second, carefully tuned laser, she created a narrow window inside that cloud where light could pass through without being absorbed. Physicists call this electromagnetically induced transparency. Here's why that window matters so much. That second laser doesn't just make the cloud transparent, it makes transparency depend sharply on color. Change the frequency just slightly, and the way the cloud bends light changes a lot. A light pulse is never one pure frequency. It's a narrow spread of them, and each one inside that spread gets slowed by a different amount. Add them back together, and the whole pulse crawls forward. On the 18th of February, 1999, Nature put the result on its cover. Other physicists had slowed light before, modestly, through ordinary materials, glass, certain crystals. Nobody had pushed it anywhere close to this, and nobody had a clear idea how far it could actually go. Light, slowed to 17 meters per second, 38 miles an hour, slower than a bicycle. The pulse compressed down to tens of micrometers, entirely contained within the cold cloud of atoms. Small enough to fit inside, something narrower than a human hair. She wasn't finished. In 2001, her team went further. They sent a pulse of light into the condensate, then switched off the coupling laser at exactly the right moment. The light stopped, completely. Its information, its pattern, held inside the atoms themselves for about a millisecond before being released, continuing on as light again. By 2007, her team had taken this further still. They stopped a light pulse the same way as before, but this time, instead of just holding it, they converted its entire pattern into a slow-moving wave of matter, a ripple in the atomic cloud itself. That matter wave, physically traveled, carried the light's original information with it, into a second, separate cloud entirely. There, it was converted back, and the original light pulse re-emerged. Light's information, briefly carried as a matter wave, then becoming light again. Here is exactly what did and didn't change. The speed of light in a vacuum is still what it always was. That number hasn't moved. What changed is the speed of a specific pulse of light, traveling through an extraordinarily engineered medium. Ordinary materials slow light modestly, through ordinary dispersion, a well-understood, everyday effect. Hau's condensate pushed that same ordinary effect to an extreme almost nobody had thought physically reachable. Light's speed in a vacuum was never in question here. That number hasn't moved. What Hau changed was a specific pulse's group velocity through an extraordinarily engineered medium. No information traveled faster than light allows, and nothing about causality was touched. The 2001 result mattered beyond the spectacle of it. Stopping light and releasing it again meant storing a pulse's information inside matter, briefly, then handing IIT back. That's a genuine building block for quantum memory, an important milestone technology that later research has continued to build on. Now here is where this gets interesting. 750-some years before that 1999 paper, a Zen teacher in Japan was working out a related question. Not about light, about time itself. His name was Dogen, 13th century, Kyoto, founder of the Soto school of Zen in Japan, and one of the most philosophically original thinkers that tradition ever produced. In 1240, while teaching at a temple south of Kyoto, he wrote a short, famously difficult essay called Uji, usually translated as being time. Scholars have been arguing over exactly what it means for more than 7 centuries since, and the argument shows no sign of settling. Dogen opens with a claim that sounds almost like wordplay at first, the kind of line you might skim past. Sit with it a moment, though, and it stops sounding like wordplay at all. Time itself, he wrote, is nothing other than being, and every being is nothing other than time. He was arguing directly against the ordinary picture most people carry without examining it. That time is a container, a river things move through, at a steady, external rate, while staying essentially themselves. Dogen rejected that picture completely. Each moment, in his account, isn't a slice cut from some larger, uniform flow. Each moment is the complete expression of whatever is happening. Right then, being and its own particular time. Inseparable. A mountain, in his writing, doesn't sit inside time the way a stone sits inside a river, waiting for the current to move it along. The mountain's existing, right now, in this specific way, is itself what its time actually is. Climb the mountain, and you haven't traveled through an unchanging landscape while the mountain stayed fixed. Both the climbing and the mountain are, in that moment, completely each other's time. Dogen had a word for this: a dharma position, a specific state of being, complete in itself, before you compare it to anything else. The essay's title started as an ordinary, forgettable Japanese phrase, at that time, or for the time being. Dogen took it apart and rebuilt an entire philosophy of existence out of it. Change the being, and you haven't just moved something through an unchanged backdrop of time, the way a train moves through an unchanging landscape. Being and its particular moment are one thing, not two. Let's be precise about what this is and what it isn't. Dogen wasn't doing physics. Uji is a meditation on impermanence, practice, and enlightenment, written for monks, inside a specific Zen Buddhist framework. He never addressed the physical speed of light, and there's no reason to think he was gesturing at anything like it. Dogen makes a related point elsewhere in the same essay, about passage itself. Spring's passage, he writes, is necessarily that which passes through spring. Nothing external does the passing. Spring doesn't move through time from outside. Spring's own unfolding simply is what that stretch of time actually was. There's no evidence Lene Hau ever encountered this text, or that anyone working on slow light research has. That connection isn't being claimed here, and doesn't need to be. What's worth noticing is narrower than that, and it's genuinely there once you set the differences aside. Both challenge, in very different ways, the intuition that reality unfolds against one uniform, unchanging backdrop, that everything passes through the same way, regardless of what it's actually made of or what condition it's actually in. Physics, working in a laboratory, found a case where light's passage turned out to depend entirely on the specific medium it moved through. A Zen teacher, working in a completely different territory, argued that being and its own time cannot be separated at all, not that time runs at different rates, but that each being's moment is its time, fully. Different tools, different questions. Worth testing something adjacent to this directly, for a moment. Notice how differently time actually passes for you, depending on what you're doing right now. An hour of genuine absorption in something you love, where you look up and it's somehow over. An hour of waiting, watching the clock. The clock says the same 60 minutes, both times. But notice, you don't actually experience a neutral 60 minutes that absorption and boredom get poured into equally. You experience two entirely different textures of duration, each one completely itself while it's happening. Dogen would say those aren't two experiences of one time. They're two times, each one complete, each one exactly what that being, in that moment, actually was. You already know this split, from the inside, better than any experiment could show you. A light pulse and a boring hour aren't the same kind of thing, but both are cases where the pace something moves at belongs to the specific condition it's in, not to a fixed backdrop, waiting patiently behind it. Back to the Harvard lab, one more time. Hau didn't set out to prove time was relative to condition. She was solving a specific technical problem about light and cold atoms, one careful experiment at a time. Dogen wasn't trying to anticipate a physics result 7 centuries early. He was trying to help students stop carrying around an assumption about time that he thought was quietly distorting how they lived, an assumption so ordinary that most people, in most centuries, never think to question it at all. Hau built a candlestick that pulled atoms from molten metal, fed a beam of them through years of refinement, and eventually cooled them nearly to stillness. Dogen took an ordinary, throwaway Japanese phrase, meant to be forgotten the moment it was spoken, and rebuilt an entire philosophy of existence out of it. 2 investigations, centuries and continents apart, neither one aware the other existed, both arriving at the same refusal. No neutral container, standing behind everything, unchanged, patient, waiting. Only what's actually there, moving at whatever rate its own condition allows. One number, fixed since before either of them worked. One ordinary phrase, forgettable the moment it was spoken, that turned out to be about everything, once someone finally took it apart. Ancient wisdom, quantum mystery, direct knowing. This is quantum gnosis.